Grade 11s, welcome mindsetters to this Math Monday. I am Looney and that is Dina. Dina, how are you doing?
Thanks, Looney. Hello, everybody. I'm doing well.
Cool. What are we doing for the mindsetters today?
Grade 11s, we are rerouting ourselves towards trigonometry, and we're going to start off with functions, that great topic that deals with the various shifts, left, right, up, down. We'll look at it all this afternoon.
All right, cool. Mindsetters, you heard it. We are doing trig functions. But then firstly, I want to tell you guys about the Test Yourself competition proudly brought to us by Casio. So all you need to do to enter and send a transfer in this great calculator is complete the Test Yourself section from the entry form. I will post the entry form on our Facebook page. Complete that, guys, and then fill in all your details as well. Press the submit button, and then remember, guys, entries do close on Friday at 12. So this Friday at 12 in the afternoon, entries close, and then it's done. You can't enter anymore, and then all the winners will be announced on next week's live show. So make sure you are tuned in next week to find out if you've won yourself this awesome calculator. How to get a hold of us: Facebook and Twitter at LearnExtra, and then you can download all the show notes, the videos, and the schedules on learn.mindset.co.za. Okay, remember, guys, simple. Test yourself, download the show notes. Oh, another thing, view and download. You can view or download the notes. So if you don't have a PDF viewer and you don't have a smartphone, you can still check out the notes. So you press on the view link. It's on our Facebook page. Then if you want to download the show notes, you can download them on our Facebook page as well. So it's time for the maths lesson, Dina.
Yes, grade 11s. As I said, it's trig functions. Let's have a look at what our lesson is all about this afternoon. We're going to investigate the effect of some parameters. And we're going to call those parameters A, B, P, and Q. And where are they situated? A will be the coefficient of a trig function. B will be the coefficient of the angle. Q will be a term that you're adding to the trig ratio, and P will be an angle that you're adding on to the given angle. So we're going to look at the sine function, and then I'm going to leave you to work on the cos function and tan function because they behave in a similar way. And then we're going to draw selected trig functions which undergo the following transformations: amplitude, period, vertical and horizontal shift. So I'm actually telling you what kind of transformations we'll find. There'll be a change in amplitude, there'll be a change in period, there'll be a vertical change, and there will be a horizontal change as well to these graphs. And we're going to identify when it is that these shifts occur. So I'm going to take you through some couple of sine graphs. As we're not going to be doing any point plotting, I'm not going to take you through a journey of how we got there. I'm just going to show you what the final results are of these graphs. And then we're going to sketch some together. You have a challenge question to work on, and there is the test yourself section as well, which asks you to draw a couple of graphs based on the features of how the parent graph undergoes its changes. So let's have a look at the challenge question. Let's just have a look. Where's the challenge question? Okay. I think we're on slide 3. There we go. Okay, challenge question. We have the graph y equals sine 2x and y equals cos of x plus 45 in the given domain, negative 180 to 180. And there are a few questions that you need to answer based on the given diagram. So for those of you who understand the effects of the parameters, can go ahead and really try that and give us some of those answers. And at the end of the show, we'll go through that question once we've identified the features. Okay, so we've got all those questions to work on. We'll keep you busy. Okay, so as I said earlier, we're going to look at the amplitude change. So if we had the graph y equals some constant multiplied by sine x, and this kind of behavior will be the same in the cos function as well as in the tan function, except there's one minor difference in the tan function. It's not a continuous curve, so therefore the amplitude is going to not exist. So the sine and the cos function has an amplitude, but the tan function doesn't. Okay, so the first graph that we have is the 2, the sine, well, the 2 sine x graph, which is this one. And what I want you to focus on is, let's just correct this a little bit. I want you to focus on the values for the quadrants of sine. So in the parent graph for a sine curve, what you'll find is if I have 0 degrees, 90, 180, 270, and 360, then my y value is at 0, my maximum is at 90, I've got another 0 at 180, I have a minimum at 270, and I have a 0 at 360. And it takes the sine curve 360 degrees for it to repeat itself. So if I go to the next 90 degrees, I'm going to get a 1. I'm going to get another 0, minimum and a maximum of and a 0. So in a period of 360 degrees, there are 3 zeros in that function. There's one maximum and there's one minimum. And the function increases and decreases between those zeros, or between those max and minima. So we first need to understand the features of that parent graph, because I know a number of you will just substitute or will fill on your table, on your calculator, what the function is, and then you'll go and plot all the points, and that's how you draw your graphs, without having any deep understanding into how the various transformations occur. And it's imperative that if you're going to go into grade 12 and even beyond with mathematics, that you understand a little bit of the features, that you're not just mechanically going through a process. So I'm not going to point plot. I'm going to work with this afternoon the features that exist, the special features that exist between a parent graph and its transformation. And the first thing you look at is what its period is, and you look at what the quadrant angles, what their various values are. So we've understood there are 3 zeros between 0 and 360. There's a max, there's a min. So those things are going to change depending on the various parameters. And the first one that we're focusing on is this coefficient. And this yellow graph here has got the coefficient of 2 sine x. So we've got y equals 2 sine x. And if we look at it now, we still have a 0 at 0 degrees. At 90 degrees, we have a 2. And that's going to be pretty obvious, because at 90 degree we had a 1, but now you're taking that ratio and you're doubling it. So every single ratio has been doubled. So you have this kind of stretching. And it's not surprising that the coefficient of the trig function stretches the graph, because that's what it does in a quadratic function. If you have x squared versus 2x squared, doubling that coefficient creates a stretch. So every point from the parent graph has been stretched. 0 cannot be stretched. 0 times 2 is still 0. But the minimum at 270, it was -1. It's now -2. And so the amplitude of that graph is the distance above the x-axis, which is now 2. So we've had a graph that's been stretched. So the coefficient stretches the graph, and it changes the amplitude. If we look at -1, then we're going to take those quadrant values and we're going to multiply them by -1. So we now have 0 times -1 is still 0, so both graphs intersect at 0. But 1 times -1 is -1, 0. -1 times -1 is +1. And so I can actually mark off my quadrant angles and just mark off my 0, my minimum, my 0, my maximum 0, and I've got a cycle of sine. So when you sketch trig graphs, it's important to understand what is a cycle doing. Because if I know what's happening in that cycle, then I can repeat myself every 90 degrees. So understand the cycle and repeat the cycle. Okay, so the green graph is actually the reflection of the parent graph y equals sine x. And so in here we have the domain, we have the range, and we have the amplitude. Range for this graph would be -1 to 1. Range for that graph would be -2 to 2. Okay, so that's how it's affected. Then we'd like to see what happens if we adding a constant to our trig ratio. So earlier on, I sketched for you the values for one cycle, so the angle versus the ratio, and at 0 degrees, at 90, at 180, at 270, and at 360. And we have the y value is 0, then we get a maximum, we get a 0, we back to a minimum, and we get a 0. So that's the cycle for sine. Now, you can appreciate that if we take the parent graph as being this graph, that we've just got those values with 2 cycles of that sine curve, then if I go to 0 and I take 0 plus 1, of course I'm going to raise that value. I'm now going to be plotting at 1. And so when I do that, I raise it all the way up to 1. And I'm going to have a 1 plus 1, so I'm going to raise my maximum to a 2. Then I'm going to raise that to a 1, raise that negative 1 to 0. And so what happens is my sine curve kind of gets high heels. It's raised by 1 unit. Every y value where it was, it's gone up by a unit. And so we now have the sine curve doing that. Okay, so very interesting. We've got a distance of 1 between the max and the parent graph, a distance of 1 there. So when we add on a constant, we're taking the current y values and we're going to add 1 onto those. So the x values stay the same, the period is unchanged. All that happens is my y values are getting an increase of 1 for every single y value. Okay, so that would be the vertical shift. Okay, and then let's just see what's happening here. That's our challenge question. We're missing some information. Okay, let's see what question 1 is about. Okay, so let's look at question 1. We're going to use the parent graph features to sketch a graph and let's look at, because I've been working with a sine with you, let's look at the graph y equals cos x. So what are the parent, what does this graph look like? And we're then going to sketch the graph. Let's sketch the graph y equals cos 2x. Okay, so we've been looking at the amplitude change, we've looked at the vertical change. Let's look at what happens if you double the angle. Grade 11s with your arms, can you show me what you think happens to the graph? Does it go up? Does it go across? Does it stretch across? Does it compress? What does it do? Okay, we're going to have a look at that in a moment. So let's firstly look at the parent graph. Okay, we do that for every single one, so we understand how the transformation is going to work. If we have 0 degrees, what happens? If we have 90 degrees, what happens? If we have 180 degrees, what happens to the parent graph? 270 and 360. Okay, cos of 0 degrees is always 1. That's where its maximum is. 90 degrees, we have a 0. At 180, we have a minimum. 270, we have a 0. And at 360, we've got a maximum. So for the cos function, we have 2 zeros, a period of 360, and we then have 2 maxima, which is very different from our sine curve. We have 2 maxima at 1, but we still have a minima at negative 1. So we've got those maxima at 0 and 360 degrees. So every 360 degrees, we have a maximum. And every 90 plus 180 degrees, we're going to have a 0. And then we've got a minimum at 180 degrees. Okay, now, if we look at the graph y equals cos 2x, we're now going to find that at 0 degrees, we're going to have twice of 0 would still be 1. But at 90 degrees, we're going to have 90 times 2 is 180. So we're now going to have the 180 value. Now, this is very interesting. If we have a maxima and a minima, what are you expecting that curve to do? Where's it going to go through? It must have a 0. So it has to have a 0 here. Okay, it's going to have a 0 there. And then if I substitute in 180 degrees, I get 180 times 2 is 360. And the cos of 360 is actually 1. And between negative 1 and 1, there's also going to be a 0. And then it repeats itself. So notice very interestingly that the period of that cos function, because it goes from 1 to 1, for 180 degrees, it must mean that the curve starts repeating itself every 180 degrees. So we actually say that the period of the function is 180 degrees. And how do we get that 180 from the 360 parent and the coefficient of 2? Can you see that relationship? So the period of any cos function will be the period of the parent graph of the parent divided by the coefficient of the angle. So that's how we're going to find every graph's period. And I think, Looney, we must take a quick break and come back just now.
Okay, cool. Mindsetters, don't go anywhere. We are going to take a very quick break, so we'll see you straight after this. Welcome back, Mindsetters, from that break. Just to tell you guys something, so if you want to improve your math skills and you need a bit of help, you can join our Mo Maths group. All you need to do is go to momaths.org, that is momaths.org, and then you join the South African group, you register there, and then the invite code for the grade 11s is 0JRN. That is the invite code for the grade 11s once you've registered to the South African group. The code is 0JRN. So if you want to improve your math skills, More Maths is for you guys. Dina?
Thanks, Looney. Right, grade 11s, we finished off with looking at how the period was affected by the coefficient of the angle. So we actually have the period of this yellow function is 180 degrees. Now there's something new for you because you've only ever worked in grade 10 with trig functions where the sine's period is 360, the cos function has got a period of 360, and the tan function has got a period of 180. All of a sudden, we've introduced a coefficient into we've given the angle a coefficient, and we have found that to get from a maximum to a maximum, it takes 180 degrees. And the way that we get that 180 degrees is if we take the period of the parent and we divide it by the coefficient of the angle. So when we're wanting to sketch this cos 2x, we're going to sketch a maximum at those points. We're going to sketch a minimum in the middle. And then what's going to happen in the middle? We're going to have this 0. So if I have to now plot the values, let's just do that. The xy values, we would have 0 degrees to give me a 1. And then I know that I'm getting a minimum -1, and I'm getting a maximum here at 180 degrees. So here I'm getting a 1. That means halfway I must be getting a minimum, and halfway between 0 and 90 I'm going to be getting that 0. So if we now test 45 degrees times 2 is 90 degrees, and the cos of 90 is 0. And halfway in between is 135. And that gives me a 0 as well. So you'll notice that from its first maximum, from its first y value, it will take us 1, 2, 3, 4 other quadrant angles to get 480. And you literally can you can go halfway, and then you can go halfway, and you can go halfway, because the quadrant angles are separated equal. Or you can say, I'm going to plot every, since I need 4 out of those, 180 degrees divided by 4. And with that, that means I'm plotting every 45 degrees. So you're always going to divide by 4 because you've got 4 quadrant angles, 90, 180, 270, and 360. So there's always 4 quadrant angles. So that's kind of standard. So my period is affected by the coefficient. And once I've got the period, I can then work out what the quadrant angles should be, or the new quadrant angles. So in other words, I'm going to get 2 cycles between 0 and 360 degrees, because as you can see, from 180 to 360, I'm going to have another 180 degrees, so my cos function is going to repeat itself there. Okay, so this 2 is also a nice value that shows how many cycles you have in the parent's period. So in 360 degrees, we're going to have 2 cycles. Okay, so let's just finish that off with y. What about y equals cos 3x? Okay, we will always start with the period. What is the period? How often does that cycle repeat itself? It will be the period of the parent, which is 360, and we're dividing it by the coefficient of the angle. So my period is 120 degrees. Okay, now we know we need to find where's it going to be maximum, where's it be a 0, where's it going to be a minimum, a 0, and a maximum. So where are those quadrants going to be? How many of them are there? 4. So we're going to plot every 120 degrees divided by 4. We're going to plot every 30 degrees. So I now know that if I have 0, I'm going to have a 30, I'm going to have a 60, I'm going to have a 90, and I'm going to have a 120. That's my first cycle. So I'm going to have a max, then I'm going to go to 0, then I'm going to go to my minimum, then a 0, then a maximum, and that cycle is going to repeat itself. Now, grade 11s, you're often given a domain. Don't look at the domain. Work out your cycle first before using that domain. Work out its repetitions, and then from the domain, go and trim your graph. Don't let the domain distract you, because your first primary focus point within trig is to look for how this cycle is repeating itself and how it's repeating itself and what its period is. What is its period? What is the y values? And then plot it. Notice I have not used a calculator. I'm trying to understand how the function transforms based on how the parent graph is changing as a result of that changed coefficient of x. Okay, so that's that function. And so if we use the parent graph features to sketch, let's sketch y equals tan 2x. Okay, it's a coefficient of the angle, so what changes? Great, the period. So the transformation is that there's going to be a period change. And what is the period going to be? Well, the first thing to ask ourselves is, what is the period of the parent graph? So y equals tan x. What is its period? Its period is 180 degrees. So I take 180 degrees and I divide that by 2 because the coefficient is 2. So what I'm saying now is that that curve, that tan function, will take 90 degrees for it to repeat itself. Now, how does the tan function behave? Okay, in the parent graph. Let's have a look at that. So if I have y equals tan x, how does it behave? I would have a 0 at 0 degrees, and I would have a 0 at 180 degrees. Halfway, I have a line that breaks the two curves. So at 90 degrees, I have an asymptote. And then at 45 degrees and at 135, I have these special values of 1. So the function approaches the asymptote, and over here it approaches the asymptote at -1. So my graph is actually made up of 2 branches. Before it starts repeating itself, it would actually repeat itself decreasing this way, and it would increase that way. So the moment it starts increasing, it starts repeating itself over here. So the tan function takes 180 degrees to repeat itself. Now, if the period changes, and you're now wanting to draw from 0 to 90 degrees, then what you're going to have is, notice how I've sketched it. I went period with the zeros. Halfway, draw your asymptote. Halfway, draw your 1 and -1 values. Notice no amplitude, there's no maximum distance above the axis. So, this y equals tan 2x. Look, I'm not even going to write the values down. I'm going to go 0 degrees, and I'm going to write here 90 degrees. Then halfway, I'm going to have 45 degrees. That's my asymptote. And halfway, I'm going to have my 1. So at 22.5, I'm going to have my 1 value. And at 67.5, I'm going to have my -1. And then the curve behaves in exactly the same way, but it's just happening at different values because the period has been affected. Okay, so the tan function behaves in the same way with the period. It needs to have what I call them kind of not really quadrant angles, but in a sense almost quadrant angles, because the period is 180 degrees, so it's not going to go through all the 4 quadrants. Okay, so nice tan function. Halfway, fill in your asymptote. Halfway, fill in 1 and -1s, and then repeat. So if the question said go to 180 degrees, you would keep repeating that pattern, or if it said go to -90, you would keep repeating that pattern. So at -22.5 degrees, you would have a -1, and you then have another asymptote, and so you keep on repeating the previous cycle, both left and right. Okay, so that would be the period change. Okay, now let's have a look at a graph, because we haven't seen this one yet. So we've seen amplitude change, which is the coefficient of the trig ratio. We've seen vertical change, which is when you add on something to the trig function. And we've seen a period change, which is the angle that's being affected by a coefficient. Now let's look at what happens when there's a value that's added to x. And grade 11s, I'm going to ask you to think a little bit about that. Where have you seen this constant being added to x? What other function in algebra has had that constant being added? Well, I'm sure some of you are putting up your hands and you're shouting at your screen, and I can hear you loud and clearly, actually. Yes, it is the parabola. Okay, remember when the parabola is written, if we just go back there. Okay, if we say y equals x minus 2 squared plus 3, what is special about this 2 is that the parent graph, which had a turning point at the origin, has been translated to the right by 2 units. So anything that's added to x translates the function horizontally. It's going to be the same thing in trig. We're not going to have new rules all of a sudden because we've changed topics. That value that you add on to the x will affect the translation. So let's go and see what that translation is. Okay, so here I have sine of x plus 30, which means really that I have sine of x minus negative 30. So my translation is to the left by 30 degrees. Okay, and then I've also got g of x equals negative 2 cos x. What does that coefficient affect? it's going to reflect that function about the x-axis, and the amplitude's going to stretch by 2 units. Okay, so the nice thing is they've sketched this graph for us already, so let's see if we're happy with what it's saying. Okay, so we've got this function over here. Which one do you think this function is? And which one do you think this one is? Okay, and grade 11s, when it's quite a lot of information, there's a grid there, there's the curves all over the place. Always focus on what's happening at 0. What's happening at 0 degrees is that this function's -2, but that function's -1/2. So I think that kind of gives it away, that the green curve is the cos function, because we were expecting this to have a -2 somewhere along the line. So we're expecting parent graph goes 1, 0, -1, 0, 1. You must sing that as a song. You must know those. So now we're going to start not at 2, but we're going to start at -2 because we're multiplying. Then we're going to go to 0, and then we're going to go to 1. And notice the domain chops that graph at 180 and -90. So that certainly is that cos function. What is the period of that cos function? Notice the angle hasn't been multiplied by anything. So the period remains. It's 360 degrees. Okay? What about the yellow function? Well, the yellow function has to be the other one. So it must be sine of x plus 30. And we said that this value affects the horizontal translation. So it shifts to the left. So whereas the parent graph was starting, I'm going to draw the parent graph for you. The parent graph would start there, and then it would go to 1, and then it would go to 0. That's your sine graph. And then it would go to -1 here. So that's my parent graph. Okay. My yellow graph is saying, hang on, translate 30 degrees. So the 0 goes back 30 degrees. So what do you think is going to happen at 90 degrees with the parent's 90 degrees? The new graph is going to translate 30 degrees left, so it's going to happen at 60 degrees. In other words, grade 11s, between -30 and 60 degrees, can you see that there's 90 degrees there? So I must still have a distance of 90 degrees because my period hasn't changed, but it's just going to be shifted 30 degrees. So notice how the 1 at 90 of the parent is now happening 30 degrees before, and how the 0 at 180 is happening at 150. So it really gives us an indication that if it's x plus 30, translation to the left by 30 degrees. If it's x minus 30, translation to the right by 30 degrees. So that factor affects where I would start. I'm not going to start at 0. I'm going to start 30 degrees before, 30 degrees after. And if there's been no change to the period, then you must remember to have a 90-degree difference between the first value you plot and the next value, which will be a maximum, and the next value, which is a 0, and the next value, which is a minimum, etc. Okay. All right, so let's have a look at some of the questions. What would f of 0 minus g of 0 be? So here's f. It's the green, it's the yellow graph. So f of 0 would be our half, and g of 0 would be -2. So a half plus 2 would be 2.5. So it's really the difference between the yellow and the green on that y-axis. For which values of x? Grade 11s, do you know how to read this? When is f greater than g of x? I want you to give that some language. What is it saying? It's saying that the y value of f must be greater than the y value of g. Okay? And if I look at my graph of f, just make sure that we've got the right one. G is the green one, okay? So f is the yellow one. So it's the y of the yellow graph must be bigger than the y of the green graph. Where do we find that representation of where one's bigger than the other on the graph? Where do we go and find it? Okay? we would start, follow my pen, we would start with a line, and we would see the green is bigger than the yellow at this x value. Then at P, they would be the same. And then as I move along, for example, at negative 60, can you see the yellow is larger than the green? And then the yellow stays larger than the green until such time as they meet. After they meet, the green takes over. And we want the yellow to be bigger. So we want these values between the y of p, the x of p, that would be x of p, and this would be x of q. And so for this statement to be true, for 3.2 to be true, we would have values between x of q and x of p. Let me just see if it includes those values. Can you see it could also be equal to? Then it could also be equal to x of p, so where they're meeting would also be inclusive. Okay. Next year, you're going to deal with equations where you can solve where those two functions are equal, where is sine of explicitly the same as negative 2 times cos x. And once you know that, you're then going to be able to find those values of p and q, and from then we could actually give those you could actually give that statement some values. But I think we're ready for a little break, aren't you?
Yes. Mindset is go get yourself some water, some juice, go relax a bit, and we'll see you straight after this break. Welcome back, Mindsetters. From that break, a lot of you are still asking me about the group that you can join if you want to improve your maths. It's called Mo Maths, so all you need to do is visit momaths.org, and then you click the South African group, and then you join and you register, and the invite code for you guys for the grade 11s is 0JRN. 0JRN. So that's the invite code for you guys. Dina?
Oh, it sounds like lots of you are joining and you're going to improve your maths by being part of the group. That's so very exciting, grade 11. That's fantastic. Right, we're now going to look at the challenge question. Luni, did we have any answers to that question?
No, we didn't.
Oh, it looks like it was too tough, hey?
Yes, people are struggling.
Any questions?
Yes, we do have a lot of questions. So you can do the challenge question and then I'll check the questions for you.
Okay, so the challenge question was, and I'm going to first analyze what's going on here, is that we've got sine 2x. Okay, grade 11, sine 2x. It's the coefficient of the angle. So what's it affecting? It's affecting the period. And how is it affecting the period? The next question is, how is the period affected? Well, it's always the period of the parent graph, 360 degrees, divided by the coefficient. So the period is now 180 degrees. And so I know that at 0, 45, 90, 135, 180, I'm going to get my zeros max, 0 min, 0. That's how my function behaves. Okay, so if I look at f, and this time around it's actually labeled for us, we didn't have to figure it out, can you see I'm going 0, 1, 0 to 180. And the period is 180, so this function here will be my sine graph. And then I have cos of x plus 45. Okay, what kind of transformation is that, grade 11s? It will be a horizontal translation, which means that there's no period change, horizontal translation to the left by 45 degrees. So it was happening at 0. It's now happening at 45 degrees, so it's minus 45. So there's my maximum. Now, if there's no period change, I must add 90, and when I add 90, I get 45 degrees. That's where my 0 is. And then I add another 90. That means I get this value here of 135. And then I add another 90, and it goes off the board, so it will just go up to there. So there's my cos function, just for me to understand how it's behaving, right? So this is y equals cos of x plus 45. And so grade 11s, take time. Take your time to understand what the transformation is talking about. Don't just jump into it and try and plot and mechanically try and do these things. You need to speak with yourself, ask a lot of questions. What transformation, what's the period, and where I'm going to plot these values in relation to my parent graph. Okay, so we've understood that my sine graph is a period change, and that one is a horizontal translation. So write down the coordinates of the points A, B, C, and D. Okay, A is the 0 of my sine graph. So grade 11s, I'm sure you can help me here. If this is negative 45 and it's got a maximum at negative 45, what is happening when it cuts the x-axis, so when it's 0? What should this value be? A max and a 0 are how many degrees apart if there's been no period change? And so yes, grade 11s, this has to be, or even if we go and try and see what this B is first, the sine curve has got a period of 180 degrees, so every 90 degrees it's going to have a 0, so this one is negative 90, which makes this one negative 135. Okay, so the coordinates of A would be negative 135 degrees, and then my y value is 0. And just as an aside, when you are asked for the coordinates, you're only going to get full marks if you've got both of the coordinates, the abscissa and the ordinate. Okay, B is going to be the x value, or should I say the x-intercept, so it's negative 90, 0, and it's not 0 degrees, that's the other thing you've got to get right, it's just the function value. And then C, where is C? Okay, C is where the cos function cuts the y-axis, and that means when x is 0. So if I substitute x equals 0, I'm going to get the cos of 45, and we all know that the cos of 45, so it would be 0 degrees, you substitute into the function, and you get root 2 over 2. Always leave it in surd form. It's more accurate than rounding off. And finally, D, where is D? Oh, there we go. We've already worked that out, that that's 135, and it's going through negative 1. So D's coordinates are 135 and negative 1. Now, I must believe that some of you did get it, but maybe you just didn't get a chance to put it onto the page. But I'm sure some of you got these values because they were straightforward function values from the way that the graphs had been transformed. Okay, what's the period of F? Who is F? F is the yellow graph. And can you see that I don't have to go and calculate that, because at the outset I must understand what transformation has happened, and if I've already worked out the period, which we have, we see that it takes 180 degrees for it to repeat itself. So it's there's a curve, so there's two curves in 360 degrees. So therefore the period is 180 degrees. Now the period is written as period subscript f for the graph that you're looking at, and it is one value. When I mark matric papers, I always find so many students losing a mark for this because they want to write it in an interval notation. And we're not saying it's just from 0 to 180 degrees. We're saying that anywhere. So if I took this value and I went 180 degrees there, I start repeating the curve. If I went there and I did a curve, I would repeat myself there. So it doesn't matter where I am on this curve, it will take 180 degrees for me to get the full cycle. Okay, so don't get it wrong. It's one value. What is the period of G? Well, that was my cos function, and the period of G did not, well, the function G did not have a coefficient of the angle. So therefore, the parent graph cos has got a period of 360. It will take 360 degrees for that curve to repeat itself. what is the maximum value of sine 2x? So if we go to the graph, what is the maximum value? At 45 degrees times 2, that's 90. Sine of 90 is 1. The maximum has not been affected. Why not? Because the coefficient of sine is 1. Hence, we're not expecting there to be an amplitude change. So the maximum value of sine 2x is 1. So the maximum value of f is equal to 1. For which values of x will the y value of the sine graph be the same as the y on the cos graph? Can you tell me where that's happening? Okay, so it's happening at this value over here. That's where they're the same. It's happening over here. That's where they're the same. And it's happening over here. That's where they're the same. So if we take the scale on this graph, this must be 15 degrees. So that's 30 and that's 45. And then we're getting this one at negative 105. So these would be my x values. And I'm just using the scale. If you were going to completely calculate this, then you would need to solve those equations, which you'll only do next year. So for now, as long as we're using the scale on the graph, it's okay, but we will make it more accurate with time. And then calculate the values of x if f of minus 45, if we would like the difference between f of minus 45 and g of minus 45. So let's go to the negative 45. Okay, here we are, negative 45. There's my g value, it's 1. And there's my, it's my g value, and that's my f value. So that's negative 1. And we just want to see, is it f minus g or is it g minus f? What is it? It's f minus g. So it's going to be negative 1 minus 1. So we would take, always look at the order. So that would be minus 1, which is minus 2. But they don't want that difference. They want to know for which x values. Well, that's really then not true because they've already told you the x value. It's minus 45. So I'm sure it's calculate the distance. Otherwise, this question doesn't make sense. Okay, and I'm going to leave it at that because I want to look at some of your questions. I'm very interested to see what you have to ask me this afternoon. So, Luni, over to you.
Okay. This one is from Nondobeko Matsane, and she's asking, can you please repeat the equation of how to calculate the cos function?
Which cos function? Because we did 2. We did cos 2x and we did cos 3x.
I think it's for the cos 2x because there's another question that links up to that as well.
Okay, so if we have y equals cos 2x, okay, I'm going to repeat the period would be, the period, if you want to write down a definition, is equal to the period of the parent divided by the coefficient of angle. So if we look at the parent cos, its period is 360, and then the coefficient is 2. So the period is 180 degrees. Okay. Now, the moment I know that I must get my full cos function, when I say full cos function, I'm talking about it's got to have a max, it's got to have a 0, it's got to have a min, it's got to have a 0, it's got to have a max. So from max to max, I'm going to need to fill in 1, 2, 3, 4 values. So I'm going to take these 4 values, this 180 degrees, and I'm going to divide that by 4. So I'm going to plot every 180 degrees divided by 4, which is 45 degrees. Okay? So I put on my sketch. I want 180 degrees. Halfway, I'm going to get a minimum. Halfway, halfway. So I'm saying 45 degrees is my first quadrant angle, then 90, then 135, then 180. And I'm now just filling in its max and its min. So it's going to have a max at 0. It's then going to come to negative there and up. So I'm only using the quadrant angles to draw the graph. And then the given domain, you will then keep going until you reach a stage where the domain says don't go further than that. So your domain will then restrict your graph. So always period number 1. Number 2, what are the intervals over which we need to be plotting? And my intervals, I need 4 of them because I need to have a 0, because that's I'm starting at 0 anyway. So I need a 0, I need a min, I need a 0, I need a max, I need 4 intervals. Okay.
Last question from up here where he's asking, why are the variables A, B, P, and Q referred to as parameters?
A parameter is something that if we change the value, we'll observe some changes. So it's a fancy English word to discuss in general what the effects of those usually coefficients or constants are actually affecting. So it's a fancy word for saying, don't just sketch y equals 2 sine x. Tell me what happens in general. So if you make it 3, you make it 4, you make it 5, what are you observing? So it's a parameter that guides that shift.
All right. We have to end now.
Oh, no, we were having so much fun. Great.
Dad, thank you so much, Dina, for the lesson. My setters, thank you so much for tuning in. Remember, guys, if we didn't get to all your questions, there is a help desk. We have all the information about all 3 help desks on our Facebook page. I'll tell you one is learn.mindset.co.za/help desk. Send your questions through there and you'll get help. We also have a Facebook app for a help desk and on Mixit as well. Check out all the information on our Facebook page. And until next time, guys, it's been great. Thank you so much for tuning in. Goodbye.